In the latest edition of our Algebra 1 video series, we'll be tackling zero and negative exponents. We're going to start today with looking at where zero and negative exponents come from. And it turns out that they come from the answers to questions where you've divided terms with exponents. So we haven't looked at this rule before, but here's how it goes. When you have to divide terms that have exponents in them, the rule is that you divide the coefficients, subtract the exponents on like bases, and put the answer in the numerator. So here's what I mean. If we were going to divide 8v to the 8v to the 7th by 4v to the 3rd, we would divide the coefficients. So 8 divided by 4 is 2, so you can think of canceling that out and making it a 2 and a 1. And then we're going to subtract the exponents on the like bases, so v and v. We're going to subtract 7 minus 3 and put that up in the numerator. So I have 2, and then we're going to have v to the 7 minus 3, and then that would all be over 1, because there's still that 1 down in the denominator. But since it's just a 1, we can get rid of it and write the final answer as 2v to the 4th. Now that looks fine, but in the second one, we have x to the 7th over x to the 11th. So what we would do is in the numerator, we would say that's going to be x to the 7 minus 11, or x to the negative 4. And suddenly, for the first time, we have not a positive exponent, but a negative exponent. The same thing is going to happen in number 3. In number 3, we have 4x squared over yx to the 4th. So there's no coefficients to divide because there's just a 4 on top and a 1 on the bottom. So I'm going to leave my 4 here. But then with the x's, I've got x and x here, so I'm going to do x to the, and I'm going to subtract the exponents, so 2 minus 4. And then I still have that y on the bottom, and there's nothing to divide it with, so it just needs to stay there. So what I have is 4 times x to the negative 2, so we have another negative exponent that has shown up with y on the bottom. So here we've got another negative. And then in number 4, I've got x and x, so I'm going to subtract my exponents. So that's x to the 8 minus 8, which gives me x to the 0 as my answer. And we need to deal with what happens with x to the 0. What does that mean? So the whole reason I'm even bringing this up, this x to the negative 4, the x to the negative 2, and the x to the 0, is that the people who decided the rules of math say that you are not allowed in your final answer to ever leave a negative exponent or a 0. You have to do something to it. So my answer to number 1 would be fine, but my answers to 2, 3, and 4 would be illegal because they have negative exponents or zeros in the answer. So that means we need a way to change this answer, to change this answer, and to change this last answer. And luckily, we've been provided with a definition of what a negative exponent means and what a 0 exponent means. So when you have a negative exponent, so like a to the negative n power up in the numerator, what that really means is a to the positive n down in the denominator. So it's the same number raised to the same base raised to the same power, but that power should be positive and it should be in the other part of the fraction. What you can also say is if your negative exponent is in the bottom, so if you have 1 over a to the negative n, it also works to say that a to the negative n in the bottom would be a to the positive n in the top. So what we're going to be doing is anytime you see a negative exponent, you're going to move that term up to the top, leave everything the same except you're going to make the exponent positive. Similarly, if you end up with a negative exponent, so the definition of any base to the 0 power is that if you raise any base to the 0, it's always going to be 1. And that's because if you think about it up here, when you have x to the 8 over x to the 8, when you have something over itself and you cancel it out, you always get 1. So when you subtract the exponents, you get x to the 0, so that has to be 1 as well. So what you want to remember is if you see a 0 exponent, that term automatically becomes 1. We're going to leave these old problems aside and look at some new ones where we use these properties for negative exponents and zeros. So when you do zero and negative exponent problems, the directions are going to say rewrite each expression so that it has no zero and no negative exponents. So if we start with 4 to the negative third, we're going to use our rules which say a base to a negative exponent in the top of the fraction is the same as putting that same base to the same exponent but positive in the bottom. And if you don't have anything in the top, once you put something in the bottom, you always want to put a 1 in the top, and that's what's in the top if there's nothing else there. You never want to leave either an empty top or put a 0 up there. So then in the bottom, 4 to the third is 4 times 4 times 4, and that's 64. So you want to do out that exponent and say that this answer is 1 over 64. Now in B, we see 7 to the 0, and you should automatically say, well, anything to the 0 always equals 1, so we're done. Doesn't matter if it's 7 or a million, if it's raised to the 0, it's 1. Now, in C, we have negative 5 raised to the negative 4th power. So using our rule, that means it's going to be 1 over, and then we're going to have negative 5, which is the base, in the bottom, with a positive 4 exponent. And if we were going to multiply that out, what you would see in the bottom would be basically 4 negative 5s. And since we're multiplying 4 negatives together, the answer is going to be positive because every 2 cancels out the negative. And when you multiply 5 together 4 times, you get 625. So your answer there is 1 over 625. Now, D looks very similar, except that the negative is not in the parentheses, which means that in this case, the 5 is the base, and that's what's being raised to the negative 4. And the negative is a negative 1 coefficient, so that's not being raised to the negative 4 power. So what that means is that when we rewrite it, the negative is like its own thing. It's like negative 1 times 5 to the negative 4. So when I rewrite it with only positive exponents, the negative 1 does not have a negative exponent, so it's going to stay on the top. And the 5 to the negative 4 is going to go down to the bottom, but it's going to be 5 to the positive 4. So I end up with negative 1 on the top, and we know that 5 to the 4th is 625. So this whole thing equals negative 1 over 625. One last thing I want to mention when we're in the number section is that negative exponents don't necessarily mean negative numbers. So we had a negative exponent here, but it was a positive, a negative exponent here, but it was a positive. Here there was a negative exponent, but the only thing that made it negative was the negative out front. Rather than making negative numbers, they usually just make your answer a fraction. Now we're going to use these same rules again, but on variables. So we're going to rewrite these variable expressions so that they don't have any 0 or negative exponents. So in A, we have 7 times w to the negative 4. So what this is like saying is, I'm going to break this up. This is like saying 7 over 1 times w to the negative 4 over 1. And we don't need to touch the 7 because there are no negative exponents there. We just need to fix the w to the negative 4 because that has a negative exponent. So the 7 over 1 is going to stay just the way it is, but in the w to the negative 4, the 1 is going to be on top instead of on the bottom, and it's going to be w to the positive 4 on the bottom. So that means that my final answer will be 7 over w to the positive 4. Notice the 7 stayed on top because it didn't have a negative exponent, only the w. In B, we've got negative 5, and that's over 1, times 1 over k to the negative 2. So if we are splitting these up, the negative 5 is on top, the k to the negative 2 is on the bottom. But if we rewrite each piece, the negative 5 has to stay exactly the same because there's no negative exponents. But now the k squared has to be positive and on top because we need to move it from the bottom to the top to make the exponent positive. So that means our final answer is just negative 5k squared with positive exponents. We do the same thing with breaking all the pieces up. In C, we have a to the 0 over 1, and then b to the negative 2 over 1. So I'm just splitting all these pieces up into fractions. and then we've got 1 over c to the negative 3 and 1 over d to the 6th. So if I change these around, a to the 0 is just 1, so I'm going to make that 1 over 1. b to the negative 2 needs to get changed. That needs to go into the bottom and become a positive 2. c to the negative 3 needs to get changed. It needs to go to the top and be a positive 3 as the exponent. And d to the 6th is positive to begin with, so we don't need to change it. So it can stay d to the 6th. So that means for my answer, and I'm going to have to intrude on d's space, all I have is a c cubed on the top with all those 1's. And on the bottom, I have multiplied together b squared d to the 6th. So by breaking it up into all of these little pieces and taking care of them separately, you can see exactly what to move, and then you multiply them all together for your final answer. So if I do that one last time with r to the negative 3 over 7, we've got r to the negative 3, and that's over 1, and then the 7's on the bottom to begin with, so that's 1 over 7. r to the negative 3 needs to get changed, so that's 1 over r to the positive 3 times 1 over 7, which didn't need to get changed because there were no negative exponents. So I can write that as 1 over 7r to the 3. So now everything's in the bottom, so we need to have that 1 in the top. And you can see that right here because it's 1 times 1 over 7r to the 3, which were multiplied together there. And let me circle this last answer. Last thing in our video is some evaluation. We're going to evaluate the expression for the given value of the variables. So what we have here is 2a to the negative 1, b to the negative 3 for a equals 6 and b equals negative 3. So I'm going to write 2 times, and then we're going to take 6 and raise that to the negative 1. And we're going to take negative 3, and I'm going to put it in parentheses because we're plugging it in for b, and raise that to the negative 3. So that means we have 2 over 1 by itself. 6 to the negative 1 is like saying 1 over 6. And negative 3 to the negative 3 is like saying 1 over negative 3 cubed. So the first thing I'm going to do is do a little scratch work for negative 3 cubed. That's negative 3 times another negative 3 times another negative 3. So that's 9 times negative 3, which is negative 27. So this means what I have here is, let me do it in another color. I've got 2 over 1 times 1 over 6 times 1 over negative 27. So if I multiply that out, first thing I'm going to do is cross cancel the 2 and the 6 and make that a 1 and that a 3. And then all I need to do is on the top I've got all of these 1's, and on the bottom I've got 3 times 27, which I know is negative 81. So your answer here is 1 over negative 81. And now we're done. So you need to remember that when you have a negative exponent, you need to put it either in the top or the bottom as a positive exponent, and if you have a 0, you need to turn that whole term into a 1. We'll do lots more practice with this in our next class.